Example 1 wants us to find log 6, and they gave us log 2 and log 3. All of these are in base 10 because they don't show us the base. I can break 6 down into the product of 2 times 3, and using the product theorem, I can break it into the summation of log 2 plus log 3, and that gives us the approximation that, using the approximations they gave us. Adding them together, I get approximately 0.778. For part B, it's the same exact thing. I see the 20. I know it's 4 times 5, but I don't have any 5s in there. But it is base 10, so use the base to your advantage. And I can break this into 2 times 10. So again, break it into, use the product theorem, break it into the summation. So now I have log 2. They gave me that approximation. And now I have log 10 with the base property, the base theorem. Log base 10 of 10 is just 1, because 10 to the 1 power is 10. So I'm going to get approximately 0.301 plus 1, and so my approximation is 1.301. If you don't have enough room here, I would suggest using the back of your paper or some other paper. I wrote it out on a big piece of paper just so I can show you the work and my thought process. It did only take 1 piece of paper. So just an FYI, if you want to follow along on paper, or in that little slot, you can do it in that slot. It's just very difficult to show work because there's not much room. So, and this itself is, what if I do this way for this? Well, it kind of works. Yeah, we'll do it this way. Okay, so if I have 1, that means I'm putting log base 5 of 1. Well, anything with that 1 in there is going to be 0. So I know the answer to 1 will be 0. They gave us the answer to 2 was R, and log base 5 of 3 is going to be S. Now, if I look at log base 5 of 4, well, that's the same as log base 5 of 2 times 2. Well, both of these are R, so I know I'm going to be getting log base 5 of 2 plus log base 5 of 2, and that's R plus R. Now let's look at 5. Log base 5 of 5, well, same base, so that equals 1. Log base 5 of 6, I can break that down into 2 times 3. They gave us 2 and 3 is R and S, so when I add these up, I'll have log base 5 of 2 plus log base 5 of 3. That'll be R plus S. 7, so log base 5 of 7. There's no product there. There's no quotient there that I know of. So we'll just skip it for now and we'll come back to it. Log base 5 of 8. Well, 8 can be a product. Log base 5 of 2 times 2 times 2. So that's going to be 3 R's. So I could also rewrite this as 2R, just an FYI. So this will be 3R. Then if I look at 9, I'm going to take this off of the paper so I can move it up a bit. Okay. If I look at 9, I'm going to get log base 5 of 9. Well, that's log base 5 of 3 times 3. So log base 5 of 3 is S. Log base 5 of 3 is S. So this will be S plus S, or 2S. Then on 10, log base 5 of 10 is log base 5 of 5 times 2. Log base 5 of 5 equals 1 plus log base 5 of 2. But log base 5 of 2 is actually R. So this is going to be 1 plus R, or R plus 1. Order doesn't matter in this case. 11, log base 5 of 11. There's no product here that I can think of to get out because 11's prime just like 7 was prime. So we'll come back to those two. Yeah, okay. And then log base 5 of 15. Well, that's log base 5 of 5 times 3. Log base 5 of 5, that's 1. Log base 5 of 3, that's S. So 1 plus S. I'll rewrite it over here. Okay, 18. Log base 5 of 18. 18 can be broken down into what factors? Log base 5, it would be 2 times 3 times 3, because it's 9 times 2. Those are the prime factorizations, but they gave us all the prime numbers for 2 and 3's logs. our R and S. So this is going to be 2 S's and 1 R. So R plus 2S, just to be alphabetical. Log base 5 of 20. So before we used, in example 1, we used base 5, base 10, we broke it 20 down into 2 times 10. Now I'm going to break 20 down into 5 times 4, but this 4 is also 2 times 2, so log base 5 of 5 is 1. Log base 5 of 2 is R. Log base 5 of 2 is also R, so it's 1 plus 2R. Log base 5 of 24, I'm going to break the 24 into its prime factorization, so that'll be a 2. Now I'm down to 12, so 2 and 2 and 3. So that's R, 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 and S, so I get 3 R's plus 1 S. 25, log base 5 of 25, well that's just squared, so 2. Log base 5 of 50, I can simplify this into 25 times 2. Log base 5 of 25 is 2. Log base 5 of 2 is R, so it's 2 plus R. 1/5, I'm getting down into negatives, so log base 5 of 1/5 is just negative 1. Log base 5 of 1/2, so 5 to the R power gets me 2, so 5 to the negative R will get me 1/2, so this is negative R. And then log base 5 of 3/5. This is a quotient. I could have done this also with these two, but this is a quotient, so I can split it into subtraction. Log base 5 of 5 is 1. Log base 5 of 3 is S, so this is S minus 1. So we do have 2 blanks, and those blanks are on our prime numbers 7 and 11 because there are no products to go along with that.